The lecture on some other methods out there. So what we've covered is quite a variety of methods, starting from the first of these lectures. We started thinking about a couple of the very important algorithms out there. K-means, that was one that we executed and we could use very nicely. It's an unsupervised algorithm that's very nice to think about. We also have something like K nearest neighbors. So K nearest neighbors is one of those algorithms that, again, very simple. These were just based upon distances between points, and that was a very nice thing about them, very simple to implement. We moved on. We started talking about the mixture models, in particular Gaussian mixture models. That was one that, again, another unsupervised algorithm that is highly effective and used quite commonly. We did linear discriminants. So this is the idea of taking some kind of projection, drawing a separation line between that data. There was naive Bayes. Which basically made use of the fact that you know something about the statistics, and you can use Bayes' rule to just simply calculate probabilities, build this function, which is the probability of one, some ratio of the probability of one versus the other, which gives you a very nice way to separate these things. And it's very easy to compute as well. And it works amazingly well, even though it's a very naive thing to do. Okay? And in the last lecture, we talked about what I think probably are the most important one, or just earlier in this lecture, with support vector machines, as well as classification and regression trees. Okay? So there's 7 data algorithms out there that you can use to do this data analysis. Almost all of these are supervised, and let me put a star on those that are unsupervised. So I better not put unsuper, because you might think that means something. K-means is unsupervised. Gaussian mixtures are unsupervised. The rest of these are basically supervised algorithms. I'll mention 3 others that are important to think about, because they actually recently have been identified as one of the other 3 top 10 algorithms out there. Actually, linear discriminant is not one of the top 10 algorithms. I put it up here because we covered it. But instead of CART, there's also this method called C45, which is a really weird name for an algorithm. But it's kind of some version of a decision tree. So I'll just put that there. So these are really 2 separate algorithms that would make up the top 10. But I'll mention some of the other ones. One of them you know, or you've heard of. It's called Pagerank. So Pagerank, you know, or you've probably heard of due to Google. So basically, Larry Page, Sergey Brin came up with this algorithm in the late 90s about how to rank web pages. And basically, they looked at the number of connections into a web page and sort of gave it a ranking based upon that, how many web pages point to another. There have been a lot of innovations around PageRank and how to do it even better, and how to get a better page ranking algorithm. So the Google one is proprietary, although people know what they did in the first versions of this thing. Because it's actually public work, but now who knows what Google is actually doing, but it's some form of page rank with some bells and whistles. Okay? The other ones are boosting algorithms, in particular what's called Adaboost. What boosting algorithms do is very much like trees. You can just start drawing decision lines, and for the ones you got wrong, so if you draw a space with points and you say, I'll just draw a separation between points, how many got right, how many got wrong, I boost the weight now of the ones I got wrong, because in my next cut, I would like to try to get those right. So I'm going to weight them more highly than the others, and what it allows me to draw is basically nonlinear classification or separation spaces, okay? So when I think about that, that's what the Adaboost does. It also can draw a circle, you know, if I have an interior set of circle points plus outside in another category, it will do very nicely and draw some kind of nonlinear classifier separating the internal from the external. So it's not just a basic line. The Adaboost is some principled way to go through and classify your data. And the final one is based upon the frequency of the data that you actually see, and this is called the a priori algorithm. And again, we didn't talk about these three in this class, but this one here, again, takes the approach of when I look at data sets and I see data that's very frequent, I want to take advantage of that. And I want to sort of start thinking about building clustering around data that I see frequently. And that's something that the a priori algorithm starts to make use of. All these build into MATLAB. All these extremely simple to use. I gave you code for all the stuff that we did here. And you saw that it's like 2 or 3 lines. The decision tree is a little bit more interesting. It takes a little bit more effort to manipulate and translate to what it actually could mean for you. But everything else is 2 lines. In some cases, 1. You simply put your training set and labels on it. It comes back with an object, which now you can put new data through to do the classification. Simple to use. It's at your fingertips. Okay. Now, I want to make this last comment. Always, always, always cross-validate your results. And I'm going to say this only once. If you don't cross-validate, you is dumb. That's the only thing that could be said about that. Cross-validation. You saw in almost everything we did that if we ran it again, it gave very different results. Okay? It's so important for you to not get deceived by either a good result or a poor result. You have to run this over many trials to see what is the accuracy. Is it robust, or it has huge variance? And that tells you a lot about your data. Always cross-validate. Or you is dumb. Tell him Cam. Cam will tell you. He might even knock you out if you don't cross-validate. Okay, that's enough for classification and clustering. On to new topics.